So today we'll be looking at this developmental pathway, which is the pathway that shows the formation of spikes in a type of beetle. And so K is responsible for repressing the gene responsible for forming spikes. I is responsible for repressing gene K, which represses E. And genes S and P are responsible for activating I. So the first mutation we'll look at is a mutation in P only. And so in this case, S would be able to activate P, but P, because it is mutant, would not be able to activate I. And in that case, I would not be able to repress K, and so K would be able to repress E, which means that no spikes would be formed in this case. The second mutation we'll be looking at is a mutation in gene I only. So in this case, S would be able to activate P. P would be able to activate I. But since I is mutant in this case, it would not be able to repress K. And so K would be free to repress E, which means that, again, no spikes would be formed. The next mutation we look at involves mutations to gene I and gene E simultaneously. And so right off the bat, we can tell if gene E is mutant, there's absolutely no way that spikes will be able to be formed because gene E was the last gene before the formation of spikes. And finally, we have a mutation in S and K. So in this case, S would not be able to activate P. So P would not be able to activate I, which means that I would not be able to repress K. But since K was mutant, it is not able to repress E, which means that in this case, spikes are able to be formed. All ectodermal cells don't have spikes because, well, the beetle likely doesn't need all of its ectodermal cells to have spikes. If all of the cells were spike-forming cells, that would likely impede the motor function and movement of the beetle. Only specific cells need spikes, and the pathway shown is how the beetle would regulate that spike formation.